Hello students, Miss Slyman here with your notes on 03.03. So we're getting back into a little bit of rationals, don't be afraid. And we're going to connect this directly with another reason we do synthetic division. So we use synthetic division to find out if things are factors quickly, but we can also use synthetic division to find slant asymptotes. So remember, slant asymptotes happen when the degree on the numerator is one more than the degree of the denominator. Slant asymptotes are diagonal lines, and they show us end behavior just like the horizontal ones. So if I think about this graph, straight away, hopefully you see that there's a vertical asymptote at x equals -1 because we can't divide by -1. Sorry, we can't divide by 0. That would happen when x is -1. All right, so I'm going carefully and slowly because you know how hard it is for me to draw straight lines on here. Horizontal asymptote, well, degree on the top is bigger than the degree on the bottom. So we don't have a horizontal asymptote, we have a slant asymptote. X-intercept? X-intercept is going to happen when the y value is equal to 0, and it looks like that's going to happen at 1, because 1 squared minus 1 would be 0. So when x is 1, y is 0. So that's at the point 1, 0. The y-intercept, when x is 0, I'm going to get 0 over 1. So that looks like it's going to be the point 0, 0, which also makes me see that I missed out on a x-intercept here. So I should have really taken the numerator and set it equal to 0. X squared minus x equals 0, and then factored x times x minus 1 equals 0, and then I would have gotten both of my x-intercepts of 1 and 0. So then my y-intercept is also 0, 0. So now it's going to be curious to see, do we go up above this? Do we come below this? What's happening with my intercepts and my asymptotes? But first of all, I want to know this slant asymptote, because somewhere there's going to be a diagonal line. And I can use my synthetic division to find that diagonal line. So I'm dividing by x plus 1, which means I'm going to put -1 in to my box. X squared power, or coefficient of x, and the constant is 0. Draw the line, bring it down, I'm going to get 1, multiply is -1, multiply that, I'm going to get, add that up, -2, multiply, +2, that's my remainder of 2. I don't actually care about the remainder so much. What this tells me, though, is that my function, when I divide, it turns into, so the answer of that division is going to be x minus 2 plus 2 over x plus 1. And I take that back. We do care about this remainder, because now when I think about x going towards positive infinity, I've got 2 divided by infinity, which is 0. But what's left, this is my x minus 2. So that's what it's going to be looking like as I go closer and closer to infinity. So here's line x minus 2. That's going to go through these points because I've got a slope of 1. Sorry, I'm going to try and draw this as carefully as I can. Doing an okay job. Getting a little bit off. There is my slant asymptote at the line x minus 2. So my slant asymptote is this part of my division, of my synthetic division. But now the remainder is going to help me think about my behavior towards the asymptotes. So I'm just going to draw that in a little clearer. That's 2 over x plus 1. All right, so somehow now I'm either going to come down, hit this, and go back up along this way. Actually, that seems to be the only thing that I can do, because otherwise I would be, I guess I could come down, up, and over that way. So yeah, let's think about our behavior. As, like I said, as x is going towards infinity, this is going to be a positive number. So I'm going to have the line x minus 2 plus a little bit. So I'm going to be above my line. So going this direction. And now thinking about x getting closer to 1 from, sorry, closer to -1 from the right side. So I'm thinking about my limit as x is going towards -1 from the right side. Well, -1 from the right side plus 1, that's going to be a positive number. And so I'm going to be getting closer and closer to, let's see, -3. But then I'm going to be adding this positive, I've got a positive decimal here. This is going to be going towards positive infinity. So the -3 is not going to take away from going towards positive infinity. So that tells me I must come through and then back up and head towards positive infinity. I think that I'm going to end up coming from the negative side. And that's because if I think about my limit, so this one is positive infinity. If I think about my limit as x going towards -1 from the negative side, I'm going to be dividing by a negative decimal here. This dividing by a negative decimal takes me really quickly to negative infinity. This part doesn't even matter, but this is -3 plus negative infinity. That's just even more towards the negative infinity sign. And now thinking about going towards negative infinity, well, negative infinity minus 2 is taking me towards negative infinity. As I go towards negative infinity, this is going to turn into a negative decimal. So making my number even more negative, I'm going to be under the line. And so there's what my graph is going to look like.